Good day, everybody. Today we are looking at integration for grade 12. The rule of integration, actually integration is a reverse of a derivation, so of a derivatives. So if you know the derivatives, you shouldn't struggle with integration. So first things first, you need to know the formulas or the derivative, the constant or the given derivative of certain functions. So this table here is gonna help us. So it's actually advisable for you to understand this table in case it's not given in your formula sheet during your exam or test. So this is how the table looks like. So we've got a function this side, we've got its derivatives this side. So for the first one, a derivative of, we've got a function which is x exponent n. Its derivative is n exponent n minus 1. Then a derivative of e exponent x is the same as e exponent x. Derivative of ln x is 1 over x. Derivative of sine x is cos x. Derivative of cos x is minus sine x. Derivative of tan x is sec squared x. Derivative of cot x is negative cosec squared x. Derivative of sec x is sec x tan x. Derivative of cosec x is negative cosec x cot x. Derivative of sine exponent minus 1 x is equals to 1 over the square root of 1 minus x squared, as is shown on the formula. And then lastly, derivative of tan negative x is 1 over 1 plus x squared. So it is important to understand this table. And so once you know the derivative, actually the integration is the opposite. So if they ask you to integrate this, you know the answer will be this. The derivative, the integration of this is actually this. So integration is the reverse of a derivative, which means it's actually this function. That's the result of an integration for this. So just bear that in mind. Then I'll give you an example. When I say integration is the reverse of a derivative, we'll use a function x exponent n. So we know the derivative of that of x exponent n is what? You have your n this side and you have x exponent n minus 1. So that's the derivative. Then when we want the integration of that, with the formula, we're bringing this constant stays the same. So we've got x exponent n minus 1 plus 1 over n minus 1 plus 1. This is actually the formula for an integration. So which we've got, then if you minus 1, negative 1 plus 1, these are cancelling each other, these are cancelling each other. You are left with n, x exponent n, and over n. The n's cancel each other. So this is the derivative, this is the integration of this function, which is actually the reverse of the derivative. I don't know if I make sense, but when we do further examples, hopefully you will understand. Then there are rules also when you do the integration. So the first rule, when you are given a function like this, a derivative of a function like this, where you've got c is any constant. So c f at x dx, then they're asking you to get an integration of that. So what you do is you take out the constant outside and then you derive the function. So therefore, if you are given an equation as c fx dx, it will look like c is fx, c integration of fx dx. Let's do an example just right here. Let's say that you were given to find the derivative of 2x dx. So according to this rule, you can take out your constant outside, then you are left with x dx. Then you can actually solve that integration. The second rule is when you've got the sum of functions. You are looking for an integration of the sum of the functions. That is actually equals to the sum of the integration of each function. So if you have fx, the derivative of fx plus gx, all in brackets dx, you can separate them as a single derivative, which is single integration, which is integration of fx dx plus integration of gx dx. So an example of this one, it will be if you are given 2x plus 3x squared, for example, dx. What this rule means, if you are given that, you can separate this. You've got 2x, derivative of 2x dx, plus derivative of 3x squared dx. And also, you see here, you can go back to the first rule. So to the first rule, you remove the constant out of this. So we've got x dx plus 3 derivative of x squared dx. Then you can now solve the integration of this, and then you multiply them by those constant. So now let's move to examples that we'll do. Let's do the exercises. So the first one is find the derivative of x cubed dx, or x exponent 3. So this will be equals to the constant. Okay, so it's x exponent 3 plus 1 over 3 plus 1 plus a constant that we don't know. So actually an equation for a derivative of xn is equals to x n plus 1 over n plus 1 plus a constant. This is actually the formula for a integration. I keep on saying derivative. A formula for integration. So that's how it is. So now our n here is 3. So it's n plus 1 over n plus 1 plus c. So our n is 3. So we've got x exponent 3 plus 1 over 3 plus 1 plus c, which is c is any constant. Then, which is giving us x exponent 4 over 4 plus c. Therefore, the integration of x cubed dx is 1 over 4 x exponent 4 plus c. And if you want to confirm your answer, you can actually take this back, derive this back. It's supposed to give you this answer as a derivative. That's how you confirm your answer, that your answer is correct. So if we were to do a derivative of this, because we said an integration is a reverse of a derivative, so we will have 1 over 4 x exponent 4, right, plus c. So if we derive this, so we will have 1 over 4 by 4 comes this side, and we have x exponent 4 minus 1, and derivative of a constant is 0. Therefore 4 cancels this one, we are left with x cubed. So that is the answer. So therefore we are just proven that this is correct. So let's do another example. So integration of 4x cubed dx. So remember the first rule, we remove the constant to the outside, right? We've got that, and we've got 4. Then now we apply the equation, x exponent 3 plus 1 over 3 plus 1 plus a constant, which is equals to 4 by x exponent 4 over 4 plus c. 4 cancels, therefore we've got x exponent 4 plus c. So that's the answer for that. Let's do another example. This is a simple one. So we first take out the constant. We've got x dx. which is equals to 2 multiplied by x exponent 1 plus 1, because we know x is actually x exponent 1, even though it's not written, over 1 plus 1, which is equals to 2x squared over 2. The 2's cancel, therefore you've got x squared. Let's do another example where you've got an integration of n by x exponent n minus 1 dx. So we take out the n to the outside, we are left with x exponent that n minus 1 dx. So it's n multiplied by x exponent n minus 1 plus 1 over n minus 1 plus 1 plus c. Don't forget to add the constant. I forget to add that c. Always add the c, because there might be a constant. We don't know what is that constant. So plus c. Then now we have n exponent a negative 1 and plus 1, they cancel, so we've got x exponent n over negative 1 plus 1, they cancel over n. Then now n cancels n, therefore the answer is x exponent n plus c. Let's do one more example. We're looking for integration of n plus 1 x exponent n dx. So we take out this from that first rule. So we've got this, then we've got n plus 1, then x exponent n plus 1 over n plus 1 plus c. Already n plus 1 cancels, so you've got x exponent n plus 1 plus c. It's as simple as that. Another example, this is actually on that second rule, where when you are given a function, a sum of functions, so you can actually separate them as integration of each function. So we're going to separate them. So here we've got integration of 1 dx plus integration of 2x dx minus integration of 3x squared dx plus integration of sine x dx, right? But from a derivative, we know that a derivative of cos x is minus sine x. So for us to get an integration of sine x, it has to be in a form of this, because we said an integration is an inverse or reverse. It's a reverse of a derivative. So for us to be able to know the integration of this, we have to put it in this way. So we're gonna put a minus sign here. So for us to put a minus sign here, it means here we're also putting a minus sign, because originally we have a positive. So this is just, you're just making sure this is taking you back there. So for you to have a negative x, you need to have a negative here for you to put you back to the original sum. So we're gonna have negative, then the integration of negative sine x. Please just bear with me. So I'm trying to say the integration, but keep on saying derivative. Hopefully you won't get lost in that. So this is that. So this is just to, at the end, we know that the derivative of negative sine x is going to give us cos x, because its derivative is a negative sign. Therefore, it's a integration of negative sine x is cos x. Derivative of cos x is negative sine x. Integration of sine x is a cos x. So now let's continue with our function. So now the first one, it's 1 by dx. So we know, okay, we've got 1, which is a constant, x exponent. So we know if it's a 1, which means actually our x was exponent 0. We know x exponent 0 is 1, right? So we've got x exponent 0 plus 1 over 0 plus 1. So just to clear the confusion, this is the same as 1x exponent 0 dx, because we know x exponent 0 is 1, so don't get confused. That's why here then we say exponent 0 plus 1 over 0 plus 1 plus 2. We are solving this one now. 2x exponent 1 plus 1 over 1 plus 1 plus minus 3 x exponent 2 plus 1 over 2 plus 1. Now minus integration of negative sine x is cos x. Therefore, now let's finish the sum. Now we've got x exponent 1. The ones will cancel, plus 2, or let's leave it here, 1 and 1, plus 2x squared over 2 plus, it's not a plus, it's a minus. Here's a minus, yeah. Minus 3 x exponent 3 over 3 minus cos x plus a constant. Please don't forget to add the constant like I'm doing. Now let's simplify it further. We've got x plus 2x squared minus 3x. No. So now they're cancelling. So 1 and 1, they cancel each other. 2 and 2 cancel. 3 cancel each other. So we are left with x plus, let's just do it at the bottom. So we are left with x plus x squared minus x cubed minus cos x plus a constant. So this is your answer. You can confirm it by getting a derivative of this, which is supposed to take you back to the original function. So it's a bit messy, but I hope you understand it. Let's do the last example. So the last example is find an integration of 3 cos x dx minus integration of half e exponent x dx. So from the formula, again, we know that a derivative of cos x is minus sine x, and we know derivative of e exponent x is e exponent x, right? So therefore we've got and derivative of sine x is cos x, right? So if derivative of sine x is cos x, therefore integration of cos x is sine x. Here we don't have any negative because derivative of sine x is cos x, therefore we are fine. We're going to leave it like this. So here we're going to have 3 cos x dx, trying to apply that first rule, minus half derivative of e exponent x dx, then which is going to be is equals to 3 sine x minus half ex plus a constant, right? Then yeah, that's about it. I tried to do as many examples as possible. Hopefully you understand. If you don't understand, please get in touch with me on the messenger, then we'll take it from there. Thank you.